Hi, I'm Susan. And I'm Julia. And we're educators here at the Museum of Science in Boston in the current Science and Technology program. This is the do-it-yourself smell bar for the topic of volatility. We've got our 3 activities, starting with the cognitive ramp using familiar situations and experiences. Then we move into the chemistry section where we look at the molecular property of volatility and how that affects the way we smell. It deals with molecules interacting with a special portion of our lining in our nose. Also in the chemistry section is the scent detective challenge. In the scent detective challenge, there's a number of different smells that we'll use to try and detect what the scents are and how they may or may not be related to each other. We can take that detection a step further when in the 3rd section, we're going to talk a little bit about why do we care about volatility and how we can detect chemicals when we talk about detecting diseases like cancer. Our cognitive ramp looks at the temperature dependence of volatility, starting with really familiar things from the home, like a scented candle, or here's a heater that heats up a wax material that you can buy to bring a lovely scent into your home. So we've got our scents in these boxes. And these boxes can be preferably plastic so that it contains the smell more when you're not trying to smell it. A box that already has a lid is a really good idea so that, again, you're not smelling it when you don't want to be smelling it. We then put in a secondary lid that has a hole cut out of it and then mesh placed in that hole so that there's room for the volatile chemicals to get out so you can smell it. In one, you can put ice so that you can test it being cold. And in the other we're using this warmer. In each, we're using this little wax piece that we would either put in the ice to be cold or to be warmed up with the warmer. So to do the activity, we'd ask the guest to predict which one of these, the cold or the warm box, would have the stronger scent. And then they get to test it out by, Usually the guests have given the right guess, and then they confirm that when they take a sniff, and that's satisfying. And there's other familiar examples you could talk about too, like homemade cookies, right? If you open the cookie jar, you can smell the cookies, but you have to stand near them. If the cookies are still baking in the oven, you can smell them anywhere in your apartment. So the higher heat is making these chemicals more volatile. We have some illustrations on these boxes that help depict that. So for cold, the molecules at the bottom of the picture represent a solid or a liquid. And then all these spaced out molecules near the top represent the gas, the molecules as a gas. For the cold, there's only a couple of molecules that are airborne as a gas. And for the warm, there's lots of molecules that are airborne. So heating up a substance gives the molecules of that substance more energy. The molecules move faster, and that makes it easier for them to break free of being a solid or a liquid and go into the gas phase. So the ability to become airborne is the molecular property of volatility. Our chemistry activity is all about smell detection. So how do we detect a smell? Well, it starts with taking in a breath. And what's going into your nose is both air molecules and many other molecules, including odorant molecules. And so those are interacting with a part of the lining of the nose. It's in the top, it's like a little bit behind where your nose sticks out from your face. And there are millions of specialized nerve cells in the lining of the nose there. So zooming in, we have this model that represents part of the nose lining. So these pink areas just represent epithelial cells, cells related to skin cells. And then these are the ends of the specialized nerve cells. We've got about 350 different types, and each type detects only one or a few chemical groups. So I'm going to inhale some of these molecules, airborne molecules, and now they're going to move across my nasal lining. I'm sure that they have to get through the mucus in there, but then they're interacting with the ends of these olfactory nerve cells.
So this one's definitely interacting with that and triggering this particular nerve cell. They're going to keep moving. Oh, this one is going to interact with this nerve cell. Keep moving across. This one's going to interact with this nerve cell. Keep moving across. And this one's going to interact with this nerve cell. And that particular pattern of those nerve cells being triggered is going to send a signal to our brain, and our brain is going to say, oh, that's chocolate. Now that we know how to detect smells using volatility, now we can be smell detectives. We give each of our visitors a basket with 4 different smells in it, along with our detective sheet that has 4 lines on it. We have our visitors then take those, and they can work as teams. Sometimes we have family versus family, or half a family versus half a family. And what they do is try to figure out first what each of the 4 smells are by smelling, writing down the number that's on the bottle, and writing down what they think that smell is. After that, when they've identified or think they've identified all 4 smells, they try to figure out which of the 4 smells doesn't belong with the others. There's no right or wrong answer here. It can be maybe 3 of them are sweet smells and 1 is a moldy smell, or 3 of them are food smells and 1's a flower smell. The visitors always write with this if they can back it up as to why they picked that particular smell.
When you've got different groups of visitors, then it's fun to see how different people chose to categorize the smells. So that can start some conversations.
So some of the smells that we use in here include chocolate, vanilla, strawberry, coconut is very popular. We use lemon. You can use, we have kind of a moldy smell, but some people think it smells like earth and they love that smell. So it's really interesting to get an idea of what people are smelling, what they think is good, what they think is bad, and again, how they're grouping those different smells together.
So we just finished the smell detection challenge. And in that challenge, we were asking people to detect 1 smell at a time. But what about when you need to discern a single smell when there's a whole bunch of smells coming at you? That's when we talk about the value of trained dogs. They can detect explosives or drugs.
They can even detect various diseases. Because when our body may have a disease of some sort or something changes in our body, that can affect the type of molecules that we might have, either in our breath, in our urine, even in our blood. And so dogs can often detect those even better than people can.
Yes, in a human nose, there's about 350 types of olfactory nerve cells. In a dog's nose, there are thousands of types, and just far more of these cells overall. We talk about, for example, some research going on at University of Pennsylvania, the PennVet Working Dog Center. They've been training dogs to detect chemicals related to disease in samples of urine and also samples of blood. They've been specializing in detecting ovarian cancer from blood samples. The research with the dogs is contributing to the development of electronic noses, sensors that can detect odorants related to illness, or maybe the electronic nose would be designed to detect explosives or drugs, or I mean, it has quite a range of applications. But we still need to figure out exactly which chemicals or which patterns are the reliable indicators. And that's where the research with the dogs can help toward the development of these e-noses. They're not ready yet, but we think in the future, electronic noses will, for one thing, be a very non-invasive method of disease detection. We might be able to just breathe across a sensor and get an answer about whether a certain cancer is present.
Now, if you're going to start talking about dogs and cool things that dogs can do, be prepared for visitors to have all sorts of personal or someone they know type anecdotes. Like, I had a friend and her dog kept smelling their knee and they went to the doctor and it turns out they had bone cancer in their knee. These stories always come up. Some are true, that's why we're using dogs to detect disease, but just be prepared for a lot of those stories to come up.
It's fantastic to engage with the visitors that way, just anything where it connects to their own lives and telling stories that help keep people engaged and help us relate volatility to everyday life.